We've done extensive work with functions and their algebraic forms or graphical forms, and we've done some work with them in tables. There was really just kind of one example that we saw. We will get more practice with those in lessons to come, but right now I want to talk about functions in context. And context means that there's a real world setting that we would need to use a function in. And let's just kind of see how that works, okay? Since it is a real world context, they are going to be described with words. So we are saying word problems without saying word problems, okay? But here we go. First example we see, we have the function p of, well, I shouldn't even call it a function, but we have the notation p of f, and this represents the number of pints of paint. Whoa, that is hard to say. The number of pints of paint needed to paint f square feet. Okay, so p is number of pints, f is number of square feet. Okay, so why is p of f a function? Okay, well, go back to the definition, right? For every domain element, there is one range element. So for any given number of square feet, that defines there's a single number of pints needed for that. We can't say, so maybe just, I'm just going to say this for now. It is impossible to use two different amounts of paint to paint the same number of square feet. Okay, so just as an example, if we have, I don't know, 20 square feet, okay, we can't use, say, 2 gallons or 2 pints and 10 pints of paint. Okay, and okay, maybe yes, you could in reality, but this is assuming maybe one coat, right? You wouldn't use 10 pints with one coat of paint for 20 square feet. Generally speaking, yeah. I mean, okay, so there may be corner cases with all this, but I mean, just don't don't think too deep. Just go surface level, and you'll be fine. What does P of 21 mean? Well, um, maybe I didn't answer the question. No, I said it. Okay, I answered the first question. What does P of 21 mean? P of 21, so F is 21, so this would be, um, so 21 equals the number of square feet, right? And P of 21 would be the number of pints, right? So P of 21 is equal to number of pints of paint needed to paint 21 square feet. Okay. So these are all typical questions that you could be asked when you're given a function in descriptive form. So explain why it's a function and explain what this means. And then domain and range. Okay. Well, how many, so domain, this is the number of square feet. So this is for F, and this would be, P of F. So what are the possible square feet that you could have? Well, in a real world context, okay, keep that in mind. Real world context, the domain, which is the number of square feet. So I need to write this down because I'm going to forget. And you're welcome to as well. Domain, I'm going to say, well, you could paint, you could have, 0 square feet to a lot, right? So Infinity might be a stretch, but you could have a lot, okay? So anything in between 0 and a lot, okay? For the range, okay, this would be the number of pints, okay? The question is, can you have 0 and can you have a lot? This is what I'm thinking. This is what I want to write. Can you have 0 pints of paint? Well, yeah, 0. I mean, if you have 0 square feet, you wouldn't have any paint to go with it, right? So 0 is a possibility. And then you can have fractional amounts of pints, right? Like you might not use a whole pint, you might use a little bit of a pint. So that would be the domain and range for this case. Okay, and for some of this, you just need to reason it through, maybe talk with somebody to, get your thinking out loud and confirm your ideas with them. Okay, next example. So it's about a weekly newspaper. Okay, so sold locally, $1.25 a copy. That's cheap for a population of 13,000. Let R of N be the amount of dollars received from the sale of N newspapers this week. Okay, explain why R of N is a function. I'll let you write it down, but if N, so N is the number of what? Sale of N newspapers. So N is the number of newspapers. So for a certain number, we have a certain revenue, right? And we can't have 2 revenues for the same number of newspapers, okay? Write an equation that models the function R of N. So we would need R of N is equal to something. Well, it says $1.25 per copy. So don't we just, to figure out the total revenue, we take the number that you sold and multiply it by $1.25. Okay, and I'm actually just going to write 125. Oops, 1.25 rather, because revenue's in dollars. Yep. Okay. Domain and range. Okay. Domain, we would like to think that it is 0 to infinity, because you could sell 0 newspapers to a lot of newspapers, right? But this notation means that you could sell like half of a newspaper, right? Can you sell like 0.5 of a newspaper? Not really, right? So what we actually need to do in this case is write it as a set that is like 0, 1, 2, 3, 4, 5, and so on. Okay, and just let it do like ... to say the pattern continues. Okay, so we can't use interval notation for the domain. So this is the number of papers sold. Okay. Yeah, we have to use just the integers positive and, well, 0, because we can't have fractional newspapers. Revenue, okay. Revenue is also maybe a little tricky. If you were to write, say, you could have an income, if you sold 0 newspapers, you'd have an income of $0, and then depending on how many you have, it's off to infinity. Yes, I say this is probably the best answer you can do, only because the alternative is really, really, really annoying. You technically have to say that it's, so this is okay. What is better would be to say it's 0, 1.25, 2.50, 3.75. So this would be like a mapping, because 0 newspapers would give you $0. 1 newspaper would give you $1.25. 2 newspapers would give you $2.50. 3 newspapers would give you $3.75. So this would be a better answer for your range. However, I understand if you were to write 0 to infinity. Okay, so contexts can be a little tricky with specifying domain and range. Okay, so be careful and make sure to check your thinking with someone. And that's really how we can really work with functions given a description. So make sure to justify why it's a function, investigate domain and range, and then analyze the notation.